Hello, everyone. Welcome back to the good stuff we've been doing. Yeah, I have a very nice and intimidating problem. We have to prove that this expression here is equals to this exactly, that they are both and the same thing. So it's quite long, though, very very long. Then you have to imagine how do we even expand x minus a to x minus b to the fourth power, and then we expand x minus b to the third power, and then we collect items and see compare with this side. How in the world do we do that? Truth is that we not even try to. Fact is that if I'm asked to solve this problem, I'll have to make some observation. Which is that here we have 1, we have 4, we have 6, and then we have 4, and then we have 1. So we have 1, 4, we have 6, we have 4, and we then have 1. So if you're familiar with the identity which says that a plus b all to the fourth power equals a to the fourth plus 4a cubed b. The power of a is decreasing while the power of b is increasing, and the coefficients are 1, 4, 6. Then you have here a square, power of a will decrease, b will increase. They have a 4 here, a will decrease, b will increase, and they have a b to the fourth power. So if you remember this identity here, you will notice quickly that here we have 1, 4, 6, and then 1, 4, 1. So it should tell us that we are expanding something like, let's say, big A minus big B all to the fourth power. That should be what we have to take note of. And not just that one, here is more. A to the fourth x minus b to the fourth power. So they both have the same power here. In the next part, they both decrease. So a third x minus b to the third power. And then we have a new term here, b x minus a, which increases here. Both of them increase. And then the a square x minus b to the fourth decrease. So if you remember this identity here next here, where for the two terms here, one of them would increase in power, then the other would decrease in power. We are going to pin that together and see what we can do. So what we can do to this problem here is to come and say, okay, we have to expand something that has to the fourth power, but the first term has to be a multiplied by x minus b, obviously. And then there is going to be a minus sign, because you have the minus, have a minus sign, plus sign, minus sign. So there's always a minus sign here. Here is why. If we expand x minus a minus b to the fourth power, you have a to the fourth. But then here, because b is negative, here will be negative 4a cubed b. And then for this part, even though b is negative, because we are going to square b, everything will be plus 6a square b square. So the signs will alternate. The signs will alternate. No, this is b to the fourth power. So what that should tell us is that here we will be having minus. Then the term that decrease in power now would be a. I think it will be have to be b x minus a. Yes. So we could have b square x minus a, b cube x minus a cube. So and then so this is minus b x, no, this everything has to be b x minus a, x minus a, right? Yeah. Then everything will be to the power of 4. So let's simplify it further. This will be ax minus ab, then have minus bx plus ab all to the fourth power. So this will equal the ab cancel out, and you have ax plus minus bx all to the fourth power. This will be same thing as a minus b x to the fourth power when we bring out the x. And no, of course, the a minus b itself, we have to take the fourth power as well. Everything then becomes a to the fourth power minus 4a cubed b plus 6a squared b squared minus 4a b to the third power plus b to the fourth power, all multiplied by x to the fourth power. So if you compare this expression now with what we have in the problem, we see that we have actually solved the problem completely. Let me compare it. I think they contain, yes. So see that we have actually solved the problem completely in just I think 1 2 3, in just 4 lines. Even this line can be skipped. You can just skip, cancel out this a b part and bring out negative b. So at first the problem looked like something that is going to consume too much time, but because we took the smart approach rather than the mindless computation, if you were a robot, you may probably, even robot will not do this. I think they will find an easier method. So please don't do this. Don't go and expand x minus b to the fourth power. Don't do it. I'm not saying that we are discriminating, but if you do this, we'll not be happy with you. The best way is to look for the shortest way to solve a problem and apply some level of ingenuity, smartness to it, just like we have done here. So a very nice problem. Here I think I have an interesting problem I wanted to solve, but give me a second. Okay, so here I'll write it down, and then you can solve it though, and then maybe when you solve it, you can just probably send it to me on Skype. I'll put my Skype address in the description below. So you said that we should prove that the problem says that we should prove that first we have uh a something like 3abc minus 2b cubed minus a squared d all to the power of 2 plus 4ac minus b squared all to the power of 3, then all over a squared. We have to prove that this whole expression is equal to, notice we have 3dcb minus 2c cubed, then we have a minus d square a. Let me give first space. Let's have a minus d squared a. Then we have 4 to the power of 2. Then we have a plus sign plus 4. What we have next is db minus c squared all to the power of 3 all over d squared. Now this problem is a very beautiful one. Notice that it's just that we change a and d, like just look d, c and b, c, that just like we change a and d, and then we get this term here. So here we have a and, but notice that here we have ac, but here we have db in place here. So it's like we change a and b and d or something like that. A very interesting problem. From this, I got it from the textbook. I Crystal Algebra. Most of the best approach to solve this problem is to prove that multiply both sides by d square. I think. Let me not spoil. Let me not give hints. But it's a very interesting problem on the topic we're covering. But I decided to solve it. I'll solve other things. This playlist is very lengthy. But if you solve it or you want a solution, you can just check my Skype in the description. Message me. We'll discuss the problem together. Thank you for your time, and please subscribe to the channel. Have a nice day.